Hello, let me introduce myself. My name is Kamila Kurnia Sari, and in this section we are going to discuss about how to determine the maximum value of linear programming using ruler method. So let's check this out. Now we need to determine the maximum value of z equal to 4x plus 5y subject to 2x plus y less than or equal to 4, 2x plus 3y less than or equal to 6, for x positive and y positive. Before it, we need to draw each graph of this constraint, and then we find the feasible area that satisfies for each constraint. We can use Geogebra application to draw the graph, and then let's do it. For the first constraint is 2x plus y less than or equal to 4 and 2x plus 3y less than or equal to 6 and x greater than or equal to 0 and y is greater than or equal to 0. So we get the graph. This is the graph of each constraint, and this is the feasible area that satisfies for each constraint. Now we need to change the inequality of each constraint into equality, so we can find the corner of the feasible area that satisfies for each constraint. So let's do it. First question is 2x plus y equal to 4, and then we show the value of first equation. So we get like this. In the same way, we can do this step for the second equation, that is 2x plus 3y equal to 6. Show value of the equation. So this is okay. For next step is we must find the corner of the feasible area, and we can use this tool, that is intersection point of two constraints or two lines. So we get intersection point on A, we got intersection point on B, we got intersection point on C, and the last we got intersection point on D. So there are 4 corner point of the feasible area. And then the next step is we need to draw the graph of the objective function, that is x is equal to 4x plus 5y to determine the maximum or the minimum value of z. And in this section we just find the maximum value of z. So let's do it. We draw the graph for the objective function, that is 4x plus 5y equal to k. This, and then we change the range of k from 0 up to 12, with the step is 1, like this. And to find the maximum value of z, we need to make this line to pass the feasible area of this system. So if we click this button, this line will pass through to the feasible area, and for the maximum value is the last point that pass by this line. So let's check. Okay, this is point B. This is the first point that passed by the objective function line. So this is not the maximum value. Okay, this is the second point that passed by this line, and this is the last point that passed by the objective function line. So we already get the maximum point, that is in the point C, that is x is equal to 1,5 and the y is 1. So we got the maximum value of z is equal to k is equal to 11, and this maximum value will get if the x is equal to 1,5 and the y is 1. So this is the maximum value of the z. So thank you for your attention.